Okay guys, welcome to my video where I'm teaching you guys how to tune PID. Specifically, I'm going to be teaching how to tune PID for the elevator because that's the example in the YAMS documentation. You can change these create elevator constants to create arm constants, or create flywheel constants, or just constants. But we're going to use elevator constants because we have an elevator here. If you are using arm, if you are making an arm, make sure that these constants get updated. If you hover over it, it'll show you all of the parameters that it needs. The Swift elevators, so the Swift Ascends, they have a 7-foot max extension. And then all of the drum radius and stuff you guys can ask me about, and I can provide that information to y'all, or you can ask one of the CAD kids and they can get that to you. So the first thing we're going to do is we're going to simulate our code. So if you click on the WPI Lab logo, look up simulate, and click it. It should say build successful. If it doesn't, then you might need to do something else. Like you might need to just check whatever error it gives you, and you can work with it. Click the Sim GUI because that's the one that we're going to use, and then it's going to open up all of this stuff. Whenever I first came in here, this network tables and network tables info were expanded. This joystick was not in the right place, and all that kind of fun stuff. So I just kind of nudge stuff around. If your keyboard is not showing up, then, or in the joysticks, if you don't have anything in your joysticks, then drag your keyboard down here. I have a guide in the Discord for all the button bindings if you want to use more buttons than the 4 that we have configured originally. But that's not going to be what we're covering today. That's for during the season, not for tuning. Next up, we want to display our mechanism. So we're going to go to network tables. We're going to go to smart dashboard. You're going to hover over the name of your mechanism. So elevator, arm, whatever it is, and then click on mechanism. So this will pop up. This green bar is your range for how much your elevator will go up and down. There will be another bar which is orange, which will show you the current position of the rope of the thing. Sorry, not of the thing, of the elevator. And so this is all we need to do to set up for this. The next thing we need to do is open up Elastic. So if you just if you downloaded WPI, you've downloaded Elastic. I've created a different, oh my goodness, I spelled that wrong. I've created a different tab for the elevator. You can too if you'd like. There are two main things that we're going to add. First is live tuning, so we can tune while we are operating the robot. This will be useful both in season and in sim, like whenever we have the robot. So in live tuning, just keep clicking. Make sure, this is the important step, make sure you've selected the correct mechanism that you're tuning, and then keep going until you get to live tuning. You can drag this out, and then there's a couple more things that we're going to add. We're going to add a tuning. So you're going to look up tuning, go to this section, go again to your mechanism, your motor, and then closed loop is what you need. So we're going to click on this, and then we're going to drag all 4 of these out here. It doesn't really matter. We're going to organize them in a little bit. And then close for now because we don't have enough space. So we're just going to shrink these a little bit because we don't need them to be too visible. Actually, these ones you should have 3 blocks wide. These ones we can keep at 2 blocks. The next thing we're going to add is position. So if we go to mechanisms, go to your mechanism, go to your motor, go to measurement, you're going to drag this position out, and then we're also going to drag velocity out from that same place. It should already be open. And then we are going to make these into 3 by 3 grids. So these are pretty important. And then we're going to right click. We're going to go to edit properties. We're going to change the widget type to a graph. I'm going to change this time to 10 seconds, and then I'm going to close. Same thing with velocity. I'm going to change it to a graph. I'm going to change the graph color just because I find it easier to work with. And then I'm going to change this to 0.5. And you'll see, actually, I'm going to change it to 0.25, not 0.5. You'll see why in a second. So now this is what your setup should look like. And then now we're going to set up these. So we are going to right click, go to edit properties, and then under children order and properties, you're going to click on each of the little text display. So here it's KD, I, and P. We're going to click on the show submit button, and then we're going to do that for all of them. So we're going to do it for this one. We're going to do it for our feed forward, and this it shouldn't take that long. And then let me just, there we go. And then now we have this little button here, and this is useful for whenever we are tuning the robot in real life, not just in sim. Because if you press the enter key to push your data or push your new values, they're gonna be you're gonna disable the robot, and that's a real pain. So I'm gonna set all these to 0, and then I will walk you guys through how to tune the robot. So now we are going to press teleoperated. So then now we can control our robot. Again, that orange thing, as I was saying, that's what you use to control your robot. Now we're going to click on elastic. We're going to click on the live tuning button, make sure it's blue. Then we're going to set this set point to something like unreasonably high. So like 10 meters, that's 30 feet. The swift ascents, again, only go up to like 7 feet. So this is we're not going to like send it into outer space. We're just tuning our kg. So kg is the force that is used to counteract gravity. So we're just going to keep increasing this until, it's going to, you can see here that the bar is going up. That means it's too high. So I'm going to bring it back down. I'm just going to set it back to 0 so it goes back down. And then I'm going to go 0.25. So 0.25, let this go. You can see it's increasing very, very slightly. We can decrease this to like 2.4249. Okay, so like this is good. 2.495, this is a good value. You really want like 3 or 4 or 5 decimal places, but this is good enough. Next up, we are going to tune KV. So KV, if you go to the official documentation from CTRE, it is in volts per rotations per second. So what that means is we're going to look at our volts and we're going to look at our rotations per second. Luckily, YAMS has a button that sets our duty cycles to a certain value. So we're going to press C, and you can see how it just stops. That's good. We're going to press, I'm actually going to change this because you see how it's like going down a little bit. I'm just going to set it to 0.25. We're going to press C on our keyboards, and then we're going to watch for velocity. So velocity is 27 point whatever number this is. So I'm going to copy that. Actually, I'm going to first look at the voltage. So our voltage is 3.552. And then I've already copied the max velocity. So now I can open up my calculator, and we're going to do volts. So 3.552 divided by our max velocity. So we do that and we get this number. I'll just copy the first like 5 digits and then publish that. So now we've got our KV done. Now we can tune our KA, and this is where this velocity graph is going to come in handy. So I'm going to set this back down, and then I'm looking at how long it takes for this bar. You see how it goes like there? You can see how it's going from this lower bar to this higher bar. I'm looking at how long it's taking to do that. So it looks like it's taking up about one of these sections. So one of those sections is 0.1 seconds. So I'm going to do volts divided by rotations per second divided by seconds. So that is literally just kV. So this value that we got here, and we're just going to divide that by our seconds, so 0.1 seconds. So then we get this value. Again, just copy the first like 4 or 5 digits, and then that's our Ka. So now we have our Kv and our Ka tuned. Now we can turn on live tuning again, because whenever you press a button on the joystick, you can see, if you look here, our live tuning turns from blue to gray. Gray means that it's inactive. That's command-based stuff, because this live tuning is a command. So whenever you're tuning, try not to touch any joystick buttons or anything like that, so then you don't accidentally undo your live tuning. So now we have our positions. I'm going to set this to a more reasonable position, like 1. And we are going to increase our Kp ever so slightly. So we're going to start with 0.1, and you can see how it's like not moving. So we're going to double it. Still not moving. I'm going to increase this to 2. That way it goes a little bit more. It just goes. So you see how there's this huge curve? I'm going to keep doubling it, because that's you can just look at it. Like if you go to 1, that's way too slow. So we're going to double it again. Increase it back. Still too slow. We're going to set it to 1. See, now it's going a little bit faster, but you see how we have this curve going here? We want it to be as straight as possible, so we're going to increase it a little bit more. That looks better, but whenever at the top, you can see how it kind of curves like that. That's not good. So we're going to do that. We're going to double it again. That looks really good. You see how it just stops there? Now let's go down, and oh, you see how it oscillated? It overshot, and then it kind of brought itself back. That's not good. If we set this position to 0, that's going to be slamming into the bottom of the thing at like Mach 10, and that's just going to break. So we had 2 before, we doubled it and got to 4, so now we're going to go something in the middle. And that looks pretty much the same. We can go back down. You see how it's still oscillating a little bit. Now but it's not nearly as bad as it was before. So we can look at it again. You see how it's like over 1, but whenever we do 3, it's like a little bit less. Once it's within like 1 box, I guess, we can start tuning our KD. We don't want it to go too slow, because as you can see, like if we go too slow, then it reaches our position really slowly. So let's tune with a KP of 3. So I'm going to set it back down again. And now I'm going to start really small with KD, because KD can get kind of jittery really quick. So you can see already from before, it's gone from like 3/4 of the box to half the box. So same thing as we do with KP, we can do with KD. We can just keep doubling it until we get like very minimal oscillations. So now we can double it again, and we can go up, and that looks pretty stable, honestly. And then we can go down, and that looks pretty good too. So now that we have a pretty good baseline here, but it's still, you can see it's kind of still slow up here. So what we can do is we can kind of go in the middle. So before we had 0.1, now we have 0.2. We can go into the middle and go 0.15, and then we can try that. So now 0.15, it's like kind of jittery, but you can see how on the way up, it's still doing that like smooth motion. That means that we can try decreasing our KP a little bit. So we can go to like 2.5 for KP, and we can just kind of play with the values. That still looks kind of slow, so I'm going to increase it a little bit more. So now we're between 2.5 and 3, and then And that looks pretty good, honestly. Like maybe we could do a little bit higher. We can try like 2.9. But our main thing is we don't want this to oscillate. You see how it kind of ticks down a little bit? Maybe we should do like 2.8. And this is like, I'm getting into the nitty gritty a little bit early here, but like this is kind of what we want. You see how now it's a lot nicer, like it looks more like a box. That's kind of what we're looking for. So basically, just to recap, and again, a lot of this is kind of going to be by feel. I've tuned a few, like I've tuned quite a bit of PIDs because of the last year and this year. So I kind of have understanding, but it's going to take time, and that's fine. It's good. It's better to practice in sim than to like. You saw how it would oscillate a lot. One time I did that on the actual robot, and it like slammed at like 30, 20 feet per second or something. So you don't want to break it, so which is why we're using sim. So that was how you tune sim. To give you a rundown, set everything to 0, set your position to something wild, turn on live tuning, set your kg, keep moving your kg up until it starts moving up a little bit using your position graph. Then you can tune kv and ka by using the duty cycle, measuring the voltage, measuring the velocity for kv, and then dividing that by how long the velocity takes to ramp up, which is your ka. After that, you can set this position to a more reasonable position, like 1 or 2, or if you're using an arm, that's in radians. I would use a calculator for that. And then based on that, you can tune your KP. Keep doubling your KP until you get to a point where it's oscillating either on the way up or more often than not on the way down. You want this oscillation to be like a box. That's kind of what I was using for the elevator. It might be different for the arm. Let me know how that goes. Once that's done, then you can start increasing your KD. You really want to start at a pretty low value. I started at 0.05 because I've already done it. But on last year's robot, I started at 0.005 and I just kept doubling until I got to a good point. One thing to watch out for, if I set this KD too high, you see how it's going really crazy right here? That's not good. You want it to be as steady as possible because any of this jittering is going to result in like that little clack noise, or like if you've ever tuned swerve, that little like really freaky noise. And we don't want that on our robot. We want it to be as smooth as possible. um, so KD is good, but it's also something that you need to like make sure that you don't mess up, or you don't tune too aggressively. Otherwise, it's going to start oscillating, and that's not good. I hope that this tutorial was helpful, and if you have any questions, just let me know. Thank you.